In Lesson 19, we're going to look at comparison shopping by using the unit price and relating the measurement conversions as well. In example 1, we're looking at mixtures of blue paint and red paint. This is similar to several lessons ago. The ratio in this example of blue paint to red paint is 1 to 2. So in our table, if we do blue paint to red paint, according to our ratio in the problem, that would be 1 cup of blue paint to 2 cups of red paint. That means if there are 2 cups of blue paint, there need to be 4 cups of red paint, because the amount of red paint has to be 2 times the amount of blue paint. The ratio translates into an equation that would be red is equal to 2 times blue, or to shorten it up, R equals 2 times B. Remember, you can show multiplication without a symbol when you are writing variables. So if there are 3 cups of blue paint, there would need to be 6 cups of red paint. 3 times 2 equals 6. And finally, if there are 4 cups of blue paint, you would need 8 cups of red paint. 4 times 2 equals 8. The second example is Miss Sipple, who's a librarian that enjoys reading, and she can read 3/4 of a book in one day. Now, this is the first time we've seen fractions for a while. Don't let them scare you, because you know something about them. The equation could be days are equal to 3/4 times books. And we could write it shorter as D equals 3/4 times B. But the important part is filling in your table. Books and days. She can read 3/4 of a book in one day. So far, so good. On the second day, on day 2, she would read 3/4 plus 3/4. To add fractions, please remember, you first of all have to have common denominators, and then you would add only the numerators. 3 plus 3 equals 6, and keep the denominator the same. You do not add the denominators. 6/4 simplifies to 1 1/2. But we may or may not want to do that as we are filling in our table. On the third day, she can read 6/4, this is from day 2, plus 3/4 more. And that would be easier to add those fractions if we kept them in improper fraction form. 3/4 plus 6/4. Remember, we only add the numerators, 6 plus 3, which is 9, and the denominator stays the same. And again, we could simplify that, giving us 2 1/4, but we might not want to do that until our table's done. Finally, on the fourth day, she can read the 9/4 that she had from day 3, plus 3/4 more. As long as the denominators are the same, we add only the numerators, and 9 plus 3 is 12. The denominator will stay the same, which is 4. And when we simplify this final answer, 12/4 is actually the same as 3. So in 4 days, we can see that she can read 3 books. Notice our original ratio of 3 to 4, 3/4, 3/4 of a book in one day. See how it fits into the table? 3 books in 4 days. Little trick there, instead of working with fractions all of the time. This is where that comes from. 3/4 of a book in one day, 3 books, 4 days. In the exercises, We have Brian and Shanice, who are both training for a bike race, and they are comparing using two different methods. Brian is using a table, and Shanice is using a graph that she's created. Brian's app shows that he has traveled 75 miles in 3 hours. The zeros in this table don't help us because multiplying times 0 will always give you 0. But the 75 and the 3 does, and so does the 6 and the 150. To make the calculation easier, we'll choose the 3 and 75. Considering our first entry, the hours would be X and our miles would be Y. What we should do is divide 75 by 3, and that will give us the rate. 75 divided by 3 is 25 miles per hour. We name our rate unit in the same order as we are reporting the numbers. So 25 miles per hour. Shanice has her information in a graph, so we will need to find some point that actually shows where that line is intersecting the grid lines. And the first place I find that is at 30 miles in 2 hours. So we will take 30 miles, divide it by 2 hours, and Shanice's rate then is 15 miles per hour. Now part B says that Shanice wants to win the bike race, and they ask us to make a new graph to show the speed that Shanice would have to ride her bike in order to beat Ryan. On your new graph, you need to make sure that you still have a title, you still have labels for your axes. Remember, this is the x-axis, and this should still be hours, and this is our y-axis, and this should still be miles. And you still need to have equal intervals labeling your two axes. Just like we have in this graph above, for every 2 lines, they're increasing by 1 on the x-axis. You cannot put them any closer together or skip sometimes and not other times. It has to be very equal and it has to be very precise. On the y-axis as well, you'll notice that for each line, it's increasing by 10. That's perfectly fine for the y-axis to have a different interval than the x-axis, but they must be equal in whatever interval you're choosing to go. For ease of this exercise, I'm going to actually graph our new points on our original graph, and you can see the difference. So starting at 0, 0, we could perhaps say that Shanice maybe is 30 miles per hour, since she has to go faster than Brian. Brian's rate was 25 miles per hour, so let's try 30 miles per hour, which means that at the first hour, Shanice will need to have a point right here. At her second hour, if she is traveling 30 miles per hour, 2-hour point, she should be at 60. 30 times 2, 60. On the third hour, that would be 3 times 30. Remember, our rate was 30. That's what we decided. And that would put her point right here. In the fourth hour, again, 4 times 30, which is 120. And that's going to take us all the way up to the top of our graph. And then we can extend with a straight edge. I don't have a straight edge with me, but you understand. And this line is steeper than her original one, but this would be straight, and it does pass through 0, so looks pretty good to us. In exercise 2, we find Braylon and Tice, who are both working at a movie store and are paid by the hour. The manager has told the boys that they both earn the same amount of money, but they don't agree. So they're keeping track of how much money they earned in order to determine if the manager was correct. Braylon has written an equation. The money he earns, M, meaning the money he earns, is equal to $10.50 per hour. 10.50 times H, where H is the number of hours. Tice, on the other hand, has made a ratio table, and in Tice's ratio table, when he worked 3 hours, he earned $34.50. So in order for us to figure out how much each of them has earned, we have to know something about reading the equations and calculating from a ratio table. Braylon, with his equation, has the rate right there in his equation. Braylon's rate then is $10.50. Tice's rate is only given to us in the table for 3 hours. So in order for us to compare, we need a unit rate. And we're going to take the $34.50 and divide it by 3 to find out what his hourly rate is. $34.50 divided by 3 equals $11.50. Now we can compare and answer the question, was the manager correct? Clearly he is not, but make sure when you answer these questions that you are specific. No, the manager is incorrect because Tice is earning $1 more per hour than Braylon. And as long as you are showing your rates somewhere, this is a good explanation. Exercise 3, our final exercise, shows Claire and Kate entering a cup stacking contest. Both girls have the same strategy: stack the cups at a constant rate so that they do not slow down at the end of the race. While practicing, they keep track of their progress, and the progress is shown in a graph and also with an equation. Claire's graph shows that she stacked 5 cups in 1 second. So in question A, at what rate does each girl stack her cups during the practice sessions? Claire is stacking 5 cups in 1 second. Kate has an equation, and so we'll look at Kate's equation. C, meaning cups, is equal to 4 times T, which is the time in seconds. So Kate's rate is 4 cups in 1 second. Kate notices that she is not stacking her cups fast enough. What would Kate's equation look like if she wanted to stack cups faster than Claire? So we need to take Kate's equation and we need to change it so that her rate, remember this constant is her rate, is greater than Claire's rate. Claire's rate is 5 cups in 1 second. So there are any number of values that would make that equation faster than Claire's. But the most important thing is we need to have C is equal to some number greater than 5. So let's choose 6 times T. This constant could be 7, could be 8, could be 9. It could be any number greater than 4 because Kate's rate was, I'm sorry, greater than 5 because Claire's rate was 5 cups in 1 second. Remember, when comparing rates and ratios, it is best to find the unit rate. Find the rate for 1. Then you can compare unit rates in any form, in tables, graphs, or equations, and any mixture of them.